this is our second video on how to do mole calculations for compounds. So that's why it's called How to Do Mole Calculations for Compound 2. And of course, you know, I thought it'd be nice if we had a nice picture of a mole over here. So this mole obviously doesn't see very well, and that's why he's feeling around. So let's move on and begin our discussion. In the last video, we saw that the molar mass of a compound can be determined by adding up the masses of all the elements in the formula. So we can find the molar mass of a compound by adding up the masses of all the elements in the formula of a compound. We can use that molar mass to convert moles to grams or to grams to moles. So, if we know the molar mass of a compound, we can use it just like we did with elements to go from moles to grams or grams to moles. To be able to count moles from grams or to count grams from moles. Let's try a problem in order to demonstrate how to convert moles to grams. What is the mass of 4.37 moles of H2O? So in other words, if I said to you, I want 4.37 moles of water, we need to figure out what mass of water would we determine in order to pour that amount into a container on the scale in order to actually have 4.37 moles of water. We're going to do this in two parts. Part 1 requires that we find the molar mass of water. Remember, the molar mass is something that we determined in the previous video. Let's go through finding the molar mass for water. Remember, we're going to count the number of each atom in the formula of the substance. For hydrogen there are 2. For oxygen there is 1. In the next part of this step, we're going to multiply the number of atoms in the formula times the mass of the atom in grams. Hydrogen has a mass of 1.01 grams per mole. We find this, remember, from the periodic table. Stop the video for a moment, go get your periodic table, and find the value 1.01 as the mass of hydrogen. Now that you've got your periodic table, and you have found the mass of hydrogen as 1.01, we mass that out in grams, grams per mole. We take the number of hydrogens, multiply it times the 1.01 grams per mole, we get 2.02 grams. Of course, oxygen, there's only one of those, and each one has a mass of 16, so that in terms of moles is 16 grams per mole. We multiply 1 times 16, we get 16 grams. Then, of course, we take those masses and add them up. So 2.02 plus 16.00 adds up to be 18.02 grams per mole. So the answer is 18.02 grams per mole. Let's move on to part 2. In part 2, we use the molar mass determined in part 1 with our ability to convert moles to grams or grams to moles. So we got the molar mass in part 1. Now we're going to use that molar mass to convert from moles to grams. Remember from the previous slide that 1 mole of water has a mass of 18.02 grams. So if 1 mole of water has a mass of 18.02 grams, then 4.37 moles of water must have a mass that is 4.37 times that of the mass of 1 mole. So we take the 4.37 moles of water, we multiply it times the fact that there's 18.02 grams per 1 mole for water, and it turns out that we have 78.7 grams of water. So therefore, if I wanted to count out 4.37 moles of water, I would put my container on the scale, hit the 0 button so that it reads 0, and add 78.7 grams of water to the container on the scale. Add water until we get to 78.7 grams, and now we know we have 4.37 moles of water. Let's try another problem. Again, we're going to do this problem in two parts. what is the mass of 0.367 moles of Na2SO4? Remember, in part 1, we determined the molar mass of the Na2SO4. And we do that by, first, counting the number of each atom in the formula of the substance. There are 2 NAs, 1 S, 4 O's. Multiplying the number of atoms in the formula times the mass of the atom in grams. And again, we go to the periodic table. We know that there's 2 sodiums. We look at the periodic table. The mass of sodium is 23. So we do that in grams. 2 times 23.00 grams per mole gives us 46 grams. There is 1 sulfur. We look again at the periodic table. We know that sulfur's atomic mass is 32.06. So 1 times 32.06 grams per mole is 32.06. And of course there are 4 oxygens. Each one has a mass of 16. That's its atomic mass. We multiply 4 times 16 grams per mole, and we come up with 64 grams. We add up those masses, and we get a mass of 142.06 grams per mole. The answer is 142.06 grams per mole. And so now we're going to move on to part 2. In part 2, we use the molar mass from part 1 to solve the problem. So, from the previous slide, we know that 1 mole of sodium sulfate, Na2SO4, is equal to 142.06 grams. So if 1 mole has a mass of 142.06 grams, then 0.367 moles must have a mass that is 0.367 times the mass of 1 mole of Na2SO4. So we take the 0.367 moles, we multiply it times the mass of 1 mole, which is 142.06 grams per mole. We get 52.13 grams of Na2SO4. So that means if I really wanted to measure out 0.367 moles of Na2SO4, I would put my beaker on a scale. I would hit the 0 button so it clears it out and reads 0 on the scale. Then I would add Na2SO4 to the container until the scale read 52.13 grams, and now I know I have 0.367 grams of Na2SO4. Let's try another problem, only this problem is a reverse problem. Previously, we were trying to figure out the mass of a certain number of moles of a compound. Now we're going to do the reverse. We're going to find the number of moles there are in a certain mass of a compound. Part 1. Just like in the previous 2 problems, we're always going to start out with part 1 and find the mass of 1 mole of the compound. Count the number of each atom in the formula of the substance. 1 calcium, 2 nitrogens, 6 oxygens. Remember, in order to count that out, the subscript 2 on the outside is multiplied times everything on the inside. So since there's 1 nitrogen on the inside, 1 times 2 is 2. Since there are 3 oxygens on the inside, 2 times 3 is 6. Multiply the number of atoms in the formula times the mass of the atom in grams. So, calcium has an atomic mass of 40.08. You multiply 1 times 40.08 grams, we get 40.08 grams. Nitrogen has an atomic mass of 14. We multiply 2 times 14 and we get a mass of 28. And oxygen, which of course there are 6 of those, each one has an atomic mass of 16. So we multiply 6 times 16 grams to give us 96. And of course we add up all of those masses, and it turns out the answer is 164.08 grams per mole. So CaNO3 in parentheses 2 has a mass of 164.08 grams per mole. Part 2. From the previous slide, we saw that 1 mole of calcium nitrate, CaNO3 in parentheses 2, has a mass of 164.08 grams. We're going to take the value given, the mass, and now instead of multiplying it, we're going to divide it by the molar mass. Because remember before we said that if 1 mole of a substance has a specific mass, then X number of moles of that substance must have a mass that is that many times the mass of 1 mole. So to do the reverse, instead of multiplying times the molar mass, we divide by the molar mass. So we take the mass of the calcium nitrate, which is 189.6 grams, and we divide it by the molar mass, the mass of 1 mole of calcium nitrate, and it turns out it's 1.16 moles of calcium nitrate. So as you recall, when we converted moles to grams, we multiplied, and when we converted grams to moles, we did the reverse and we divided. To help you remember which one to do, use this diagram here. This has been mentioned to you before, and again, you can use this anytime you want. Okay? Just remember, in part 1, we find the mass of 1 mole of that substance. To convert moles to grams, we take the moles and we multiply it times the molar mass to give us the number of grams. So we follow the down arrow, starting with moles, multiply times the molar mass to give us the number of grams. Or to do the reverse, start with the grams, follow the arrow up. Take the grams and divide the grams by the molar mass to get the number of moles. So always go outwards, inwards, and then down. Outwards, inwards, and then down. Right? We're going to go moles to grams, so we take the number of moles, we multiply times the molar mass to get the number of grams. If we want to go from grams to moles, we go outwards and divide the grams by the molar mass to get the number of moles. And this ends our video on how to do mole calculations, part 2. For compounds, of course.